Hello, my friends. In this lab, we will explore the implementation of FHRP, specifically Cisco's proprietary protocol HSRP, which actually stands for Hot Standby Router Protocol. HSRP is a FHRP. This also means First Hop Redundancy Protocol used in computer networks. It's like by checking the current situation where the packets should be sent first. This gives the answer to this question. By allowing this provides high availability, fault tolerance, by allowing the multiple routers to work together as a single virtual router. For this lab, we will be using HSRP version 2. This version supports IPv6 addresses also. And also allows for the configuration for multiple HSRP groups, in this case VLANs. But in this lab, we will focus on VLAN 1 only. Before we begin, we can look at the lab topology and check the diagram for necessary details. Our goal is to configure the HSRP to enable redundancy and load balancing between the two routers. We will designate one router as active router, which is responsible for forwarding the traffic, and the other will be a standby router. In case of failure, it will be ready to take over as active. We will arrange this by using the priority command. The highest priority will always taken as active router. So we will start by assigning the virtual IP address of 10.0010/24 as the default gateway for our network. This will be set in the PCs. Additionally, we will also assign the IP addresses, real IP addresses of the routers. So we will set the HSRP configuration. When everything is finished, we will simulate if there's a router failure by cutting the links of the interfaces on the routers. We will check how the pings are sent, or if the other standby router will be taken as active router or not. We will do this by pinging the router main, which has an loopback interface of 3333. You can also use trace RT command instead of using the packet tracer simulation to follow up where the packets are going. In the end, we will also demonstrate how the preempt command is taking the effect. This command actually allows the standby router to take over as the active router if it has higher priority immediately without waiting the other router to fail first. By the end of this lab, you will have a clear understanding of FHRP, specifically Cisco's HSRP, and its role in providing redundancy and high availability in network environments. So let's get started and dive into our lab. Okay, so we can start with the R1 first. That will be active router. Enable config terminal. We'll set the host name. Keyboard problem. Okay. Then we will set the loopback interface first. IP at 1111/32 it will be. Then I will set the G00 interface 10.0.1.1/29 and no shutdown. Then let's define the let's check the IP first. Okay, up down. Router OSPF I will define so it will be easier. network 0000, wildcard all, area 0. I will define all the network interface, then passive interfaces will be L0 and G01. Okay, let's save it. Then we export it as running config. Okay. So let's go here, copy this one, change this to our main. It will be third router 333. Okay. Then copy another one. This will be the standby router. ST. Okay. Let's go with our main. And okay, RM. We can say it like that. In the topology, this will be 3, 3, 3. And this will be 2, 3, sorry. Second router is 2. Then I need to add G02 interface. So let's copy here and go down here. Yes, it is this one. It will be 2.3. OSPF looks like okay. Only one passive interface is extra. Actually, we are not using G01, but anyway, let's cancel this. We only want loopback 0 as a passive interface. So let's I also forget something here. I need to add the IP address for the G01. This is the real IP address for the default router. Okay, the other one is still down, G00. It will be up after we finish. I will paste it over ST so it will be easier to set up. First, I will put our main and enable reload the router. Okay, router name came. I can check the IP addresses or yeah, it's like all is up. I ping the first router, so routing protocol is working properly. Let's check. Okay, there's something came. Let's go to ST standby router. Sorry, I don't need this. Change the name of this one, ST. Then we go this one 2222. This will be 00. Actually 00 is not used. G01 and 2 is used, so this will be 2. I will change this. Let's cut it. This will be 02, and I will cut this one and delete. I don't leave the space. And this will change as 2, and actually this is 22. Okay. Other things are okay, seems like. Let's try this one. Okay. Enable reload. We can see the IP addresses like this thanks to packet tracer. This is set up, up, up. And this is 10.0.2, 2.2. Okay. We can also check the protocol. OSPF is defined. All networks. And we see the ping is working. We can also see the 3.3. Okay, let's check the PCs. As you see here, this is the default router, virtual IP address of the default router. I copied this. I also tried to ping here to show you that although we put 10.001, it's not reaching because default router is not 0.1 or 0.2. So let's continue with the standby setup. Go into the standby interface, we can say it like that. I use version 2, then standby 1 because we are using VLAN 1. I hid the IP address as this default router address that I copy. There's nothing. Okay, then let's check the comments. What we can do. Use priority. I use as 100, for example. Then I will use preempt command immediately first. Okay, when we ping, we should ping it 1.1 and it should ping 3.3 also, of course. Okay. Try it here also. It's also working good. I will set up this side also, config T, interface G01, the same interface. No IP. Standby version 2 first. It should be same version. Then standby 1 IP. Same IP, virtual IP address. Then I will say priority preempt. Then priority will be, let's put it higher, 200 for example. Okay, actually this becomes active router immediately. I see in the line, but sorry, let's check here. Check command show standby. You can say standby brief. State is active. Priority 200 local. Local active is local. Okay. Check this site and show stand brief. Standby is local here. So this is standby router now. We can also check it by pinging in the simulation. Start. As you can see, it goes from the router 2 first. When replying back, it can go from the other side, but first it goes to the second router. Now try it. I cut the link, so this goes the other router. After failover, it takes over as active router. Let's continue with more testing. For example, I will connect it again. Actually, I put the wrong cable, but it's working somehow. Let's try to ping again. It will again go from R2 because it has the highest priority. The preempt command lets R2 to become active as immediately. If we check brief again, standby. This R1 is now standby. So let's go to config terminal. Interface in standby 1. Change the priority here by setting it, let's say, maximum is 255, so let's say 201. Even with one difference, it already become active, as you can see the message, but let's check. Okay, active local. So let's ping. It's going from the R1. Actually, I say RAC, RST, but it doesn't matter now. We are changing the priority, so it's not important. Let's come here. First, I will change the preempt as no preempt, so I will cancel the preempt command in this router. And okay, it's taken out. It's taken out now, preempt command. For example, when we look at this, it is preempt and 201. So let's change this standby 1 priority, like 240, for example. Normally, if there was preempt, it should take over. But we didn't see any message. So let's check here, standby brief. This router is still in standby mode. So if we ping it, it will go through R1 again, as you can see. Okay, so let's cut the link. When we cut the link, now the R2 should take the control, and even I put the wrong cable, it will work again. Let's go to simulation mode, ping. Now R2 is still as active. One last thing, we can also use trace RT command in the PCs to follow the packets. For example, now it is going through second routers, 0.2, to reach the third router. And let's use this one. Still, even it's closer from the left side, it still follows the second router as default gateway. Let's cut this link and follow up what's happening. As you can see, it goes through the first router. First router becomes the active router.